Okay, welcome back to another mid-year exam question 2020 mid-year exam. This is the Criterion 6 solutions, and this is the final video. So question 4, Criterion 6. So a student built an electric circuit to investigate the properties of an unknown electrical component and recorded the following data about it. Okay, great. Calculate the resistance of the filament. Okay, so we just need to grab a point anywhere where we can kind of see. We'll grab one on the red line somewhere. Let's see. Where do we want to go from? Let's see. Let's try and get that one. So that's like on a nice little. It's on squares there. So that's our first one. Let's have a look at. Can we find another one where it's nicely through the middle? You might want to choose some different one. I'm going to choose this one. So what's that? So to work out what our scale is of the squares. So this is V over I. Okay, so remember that if we do our triangle, some people like this, V, I, R. So we're looking for resistance, okay? So R equals V over I. And in this case, it'll be equal to rise over run, because as we rise up there, it's voltage, and the run is there. That's current. Okay, so what's the value? So if we've got 0.2, what are all our little squares equal to? Might have been easier just to go on the 0.2. So, but let's see. So go 0.2. We've got 5 squares. Y and I working this out. 0.2 divided by 5. Should I know this? Should that be easy? 0.2 divided by 5. Why is my brain not working? 0.04. Okay. So this one here will be 0.28 along the voltage. This one here is 0.24. This one here will be 0.76, because 0.24 along each one. Yep, 0.76. That's one. These ones are quite hard to actually. 0.84. Okay, right. So calculate the resistance of the filament. So R equals V over I, which equals rise over run. So our rise is 0.84. You might want to choose different values. Minus 0.28 over 0.76 minus 0.24. I feel like I made this hard for myself. Why not just choose something that's on the actual graph? But anyway, we're doing it this way now. So 0.84 minus 0.28. Oh, that's divided by. Goodness gracious me. Let's do it all in one go. 0.84 minus 0.28. The last video, I'm making mistakes in the last video of the day. 0.76 minus 0.24. So it's 1.07 or 0.8, 1.08. Okay, 1.08 ohms. If you got something like 1.1 or 1.1 roughly, that's probably going to be close enough. I reckon 1.1. If you got anywhere around there, that's pretty good. Based on the available data, is the resistor ohmic or non-ohmic? It is ohmic. Ohmic as it follows Ohm's law. And that is resistance remains constant as V and I increase. Okay, so the relationship stays the same all the way up there. It's got a straight line, so the relationship between V and I stays the same, which means the resistance stays the same. And that'll work if you switch the axes around. Often you'll see current up here and voltage along there. It means the same. and it should, if it's straight line, then it's fine. And it's ohmic. It is common to have 100-watt light globes in homes powered by 240-volt mains electricity. Calculate the current drawn by such a globe. Okay, so I equals V over R, as we've seen with Ohm's law, which is equal to 240. Oh, it's a watt, isn't it? Gee, just jumping in today. We haven't been given these. Hope you're not just following me blindly. Hope you're having a go at these before. This is power. This is V. Okay, now let's have a look. When we have P is equal to VI. P equals VI. So therefore, I equals P over V, which is equal to 100 divided by 240, which is equal to 0.42 amps. Calculate the amount of energy required to use the globe for 6 hours per day for 1 year in megajoules. Okay, so P, if we go back here, let's see, where's P? Remember that P is equal to energy over time. So that means that energy is equal to P times time. P times time. Okay, so power is equal to 100 watts. Time is equal to 6 hours. 6 hours per day. So 6 times 60 minutes times 60 seconds, or you could times that by 3,600. So that's time, isn't it? For 1 year times 365. We'll assume it's not a leap year. Okay, so 100 watts. Let's have a look. 100 times 6 times 60 times 60 times 365. Woof. Okay, so how much is that? 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 7.884 times 10 to the 8, which is equal to 788.4 times 10 to the 6. They are both in joules. Okay. And that is equal to 788.4 megajoules. It's quite a lot. Okay, if domestic electricity is charged at 26.4 cents per kilowatt hour, determine the cost of using the globe for 6 hours per day in 1 year. Okay. Okay, so this is in this one you have to remember that 1 kilowatt hour equals 3.6 megajoules. Okay, so that means therefore 1 megajoule equals 1 over 3.6 kilowatt hours, right? Okay, so that means that 788.4 megajoules equals 788.4 divided by 3.6 kilowatt hours, which is equal to 0.4 divided by 3.6 is equal to 219. That's a nice number. It's an even number. 219 kilowatt hours. So that means that it is going to cost 219 times by 26.4, which is equal to 5,781.6 cents. Okay, so it's equal to $5.78. So $5.78 to run a globe for a year, which isn't too bad, I guess. That's the end of paper and the end of our mid-year exam. Okay, well done if you made it all the way through. I hope you learned something and hopefully you're going well with the study. Okay, good luck. Bye.